like a toad or a mouse, it will take those jaws and push them forward and then grab those teeth into the prey. And then it'll push the other side forward, grab those recurved teeth into the prey, and then it essentially is walking that mouse or that toad into the throat of the snake. So we have a combination of recurved teeth, craniokinesis, and the ability to operate our lower jaws independently that allow these animals to manipulate food items and to take in very large and very odd-shaped structures as well. Some snakes will have a venom. And if they have a venom, they usually have a way of delivering that venom into the prey. So they have a fang. Okay? So you all know this, that many snakes will take prey that are larger, seemingly larger than the snake itself. All right? Definitely larger than the head area. And it should be better if the snake could immobilize that prey item so that it's not struggling as so much. It's not struggling so much, potentially doing damage to the snake itself. Now, some snakes will do it by constricting. All right, so a boa constrictor will wrap itself around and ultimately prevent that animal from breathing. It will suffocate, and then the boa can take in that dead animal without having to worry about it struggling and biting in self-defense. Others will use venom, not all of them. It's about 300 out of 2,000 species. So a fair percentage, 15% of snakes will use a venom, but certainly not all snakes do. Those that use venom, I think, are restricted to 4 families. Of the Elapidae, the Hydrophiidae, the Viperidae. What's the other one? Anybody know? Believe it or not, the Colubridae. So, about 15% of all snakes are venomous, but they are restricted, I believe, to just those 4 families. The venom is produced by a modified salivary gland. It's homologous to your parotid salivary gland. And you have a number of different pairs of salivary glands. One of the largest is the parotid. And in these snakes, they are taking that parotid salivary gland and modifying the secretions to form this venom. Now, what's that venom going to do? Well, broadly speaking, there are 3 major effects of snake venom. Okay, we can have neurotoxic, hemolytic venom, and necrotoxic venoms. Neurotoxic venoms are ultimately going to cause paralysis and or respiratory failure. And they usually do this by interfering with acetylcholinesterase. So you have acetylcholine that is involved in muscle contraction. You have acetylcholinesterase, an enzyme that will release that molecule so that the muscle can relax. Most neurotoxic venoms interfere with that somehow, so that, for example, it could keep acetylcholine bound in the muscle. That would cause tetanus. Okay, you would not be able to relax your muscles, and of course, ultimately would cause death. Other types of neurotoxic ones mimic acetylcholine, and binds to the receptors. That then is going to cause problems in your muscle contraction as well. You're not going to be able to contract. Okay, so by interfering with the work of that enzyme, you can either cause the muscles to remain in a contracted state or have it so that they're not able to contract. Either way, you end up with paralysis and or respiratory failure and ultimately death. Okay? So you're interfering with nerve-muscle communication is what you're doing. Your elapids and your hydrophiids are primarily neurotoxic in their effects. So the venoms of those two families are primarily neurotoxic. If your venom is hemolytic, it can have a number of different effects. Oh, you can have, let's spell it right, hemorrhagens in it, thrombases, and hemolysins. So these are three broad categories of chemicals that would be in a venom that is categorized as hemolytic. Hemorrhagens, thrombases, hemolysins. What's a hemorrhage? Sure, it's bleeding. And hemorrhagens destroy the internal lining of the circulatory system. Right? It's a very thin lining called the endothelium. Hemorrhagens will destroy that. The net effect is that blood then starts escaping from inside the circulatory system. So you're starting to get internal bleeding. What's a thrombosis? Yeah, it's a blood clot. So a thrombase is a chemical which induces a blood clot. So hemorrhagens give you internal bleeding. Thrombases cause your blood to clot. Not good. And then hemolysins will destroy red blood cells. They lyse red blood cells. Any one of those three is not a very good thing to have happen to you. Right? So it's going to prevent you then from having your blood taking oxygen to all parts of your body in the same efficient manner as before. Some venoms are primarily, this hemolytic is characteristic of the Viperidae. Their venom is primarily hemolytic in nature. Many snakes also include a necrotic agent in their venom. And this actually starts to cause tissue breakdown. So in effect, it's initiating digestion before that prey item is actually into the digestive system of the snake. So there are many snakes in the New World tropics that if you get bitten by them, not only do you have to worry about dying from it, but you can lose whole patches of your skin surrounding the area, skin and muscle tissue underneath, in the area surrounding that bite because of the necrotic effects of that chemical in the venom. We can classify individual venoms as primarily neurotoxic, or hemolytic, but in reality, most of them are mixed. They will have more than one effect. Yeah.
Are necrotoxins specific to a family or things?
No, nope, not specific. And again, we're making generalities. So you can find an elapid whose toxin might have some hemolytic effects or might have some necrotoxic effects. But in general, its primary effect is neurotoxic. Okay, so the other end of the coin, so to speak, are the fangs. So you have your modified salivary gland. It's making this poison. You need to put that poison into your prey. And snakes will do this by using fangs. A fang is simply a modified tooth. And that tooth is going to be hollow, or it may just be grooved. But either way, you have the gland, and then you have a duct coming out of the gland, leading to that hollow tooth or to that groove along the tooth. So that when that snake strikes, smooth muscles around the gland will contract, forcing the venom out through the duct and then through the tooth or along the groove and into your prey. We have different kinds of fangs. Pistoglyphus, Proteroglyphus, or Selenoglyphus. So the glyph is just referring to the fang, and the first part is telling you something about it. So for example, with a Pistoglyphus, what's a pisto mean?
Before.
Close.
In front.
In back.
Oh, in back.
A pisto always means to the rear or in back of, right? It's a standard anatomical little prefix that's used all the time. So these are fangs then that are located in the back of the mouth, in the back of the tooth row. They're rigid and erect, and we're going to contrast that with the other ones. All right, rigid and erect, fairly short. Since it's in the back of the mouth, you inject it after that prey is already quite a ways into your mouth. So that struggling animal has a chance to bite you back and do whatever it wants to do to escape until you get into the back of the snake's mouth, and then those fangs can deliver the poison. This is not very common. Pistoglyphus is not very common. We only find it in the poisonous colubrids. So these are the least problem for human beings. In order to get the venom of an Opistoglyphus snake into your system, you essentially have to stick your finger into the back of its mouth. Right? It cannot reach out and stab at you with fangs, because they're in the back of the mouth, they're fairly short. Protero, pro, you can see front. These are going to be fangs that are in the front of the mouth, so that the animal, the snake, can strike out and make contact with the prey using these fangs that are located in the front. So it's capable of injecting that venom into the prey. Yeah?
With the Opistoglyphus, if not to immobilize the prey before eating, what would be the main function of the venom then?
It does reduce the amount of struggling in the long run. Right? So that once the animal's first contacted, there's no venom and it's struggling mightily. But as soon as it gets a little bit back into the mouth, then you can put the prey into it, which will make the rest of the job a lot easier. Proteroglyphus, they're in the front. These two are rigid and erect. They tend to be, let's say here's your fang coming down. So they're larger than the other teeth, and they'll fit inside a pocket in the lower jaw. So there's a little space for them to go into there.